cranking numbers on this, what would be a really good safety idea?
See if it's balanced.
Yeah, be sure it is balanced. Okay, so we have P4. Remember, phosphorus is one of those things that's not monatomic or diatomic. It's an exception, but you don't have to remember that. And we're going to react it with oxygen, and we're going to get P4O10. This is interesting stuff. If it gets to moisture, it turns into phosphoric acid, and it's a very, I think I told the story, it's a very fine powder, like baby powder almost in its appearance. So if you got a hunk of it on the table and you inhale it by accident, I mean, you're not snorting it, none of you that student. But if you're working with it in lab and some puffs up, you get it in your nose and your mouth, you've just become an acid factory. Because whenever it hits moisture, but it's bad when it hits moisture and reacts and gives you phosphoric acid, it's also extremely exothermic. So it's giving off lots of heat. So not only are you burning from chemicals, you're burning from temperature as well. Okay, are we balanced okay? Yeah, okay, it's safe. All right, how many grams of P4 react with 1.50 moles of oxygen? Okay, so what have we got? We got this old thing again, right here. So it's not a different problem than before, except at least they gave us a different equation, so we got to work with different coefficients this time. So, what's my unknown when you look at that? Alex, what's my unknown?
Phosphorus?
Yes, X grams. Unknown. And our known then is the oxygen, and I have 1.50 moles of the known. Okay, am I going to need any formula weights here? Okay, what?
Phosphorus.
Phosphorus. So we got to look up there for phosphorus. What family is phosphorus in? 5. Everybody spotted? Right there. Okay, so, but I've got 4 of them. So let's have a formula weight on that. Marco, do you have it? I want a formula weight for P4. And let's call a phosphorus 31. 31.0. 124? Okay. 124 grams per mole. Everybody catch our rounded phosphorus? I should have asked one of you to do it for me. Here, 31.0, because when you start rounding, see you got a 7 there, we're going to send it up to 31. So 31.0. Okay, let's do it. Since we're going for grams of unknown, that means 3 sets of parentheses. Nina, what goes in the first set?
Would be the 1.50.
Yeah. Nina, why didn't I need the formula weight of oxygen?
Oh, because it's already in moles.
Already in moles. Okay, now I need a mole ratio. Timothy, hit it.
1 mole of phosphorus over 5 moles of oxygen.
Good. I'm telling you, you've been asking about that. Do you see where he's getting that? Okay. Now, what do I have in the last place here, Erin?
You times it by 124 grams per mole of P4.
Okay, of the P4, exactly. Now, if we go back to our unit analysis, remember that's always your insurance. Moles and moles of oxygen cancel. Got to be moles of the same junk. Okay, moles of phosphorus, moles of phosphorus. Okay, if you're rusty on your calculator, take the safe way. 1.50 times 1 times 124. Get an answer, write it down. Then you're going to divide that answer by 5. Or, if you're slick, I would go 1.50 divided by 5, get an answer, multiplied by 1.24, or not 1.24, 124. So whatever you're safe with. Emily, what, or not Emily, Sarah, what did you get?
37.2
37.2 grams
of phosphorus.
P4, phosphorus. Okay, everybody get that okay? Anybody have a question on that one?
What did you write into 124 there?
1 mole of it. I put the grams per mole. Just, I could have I could have just said grams per mole, like that. I was just trying to make sure you knew what's the numerator, what's the denominator there. Okay, then, let's see what's next. I think we're ready to move on to the big time here. Okay, the next thing I want to do is to start the next section, which is a little variation on what we've been doing. And this next section is called Limiting and Excess. And what I've got penciled over there on the side are some of the problems in OWL that pertain to this limiting and excess. And this is section 3-3. So we just wrapped up and worked a load of problems here in 3-2. Now, let me tell you a crazy analogy here about this limiting and excess idea, because people have trouble sometimes with the idea of limiting and excess. Okay, here's the analogy, not to be found in the book. Let's say we own a computer dating service. Okay, and our computer dating service is very conservative. Okay, so we want to set people up on one date for the weekend. They can only go out once. So they can go out Friday night or Saturday night or Sunday night, but only one time. Also, we only allow one male and one female. Again, no value judgment, I don't care what you all do. But for our computer dating service, one male, one female, no trios, no other combinations. Okay? So, let's say 8 men fill out the application. We do a background search. They're not serial killers, so we'll take their money. So 8 men have called in for this coming weekend, and 5 women have fixed up their applications. You know we don't have to check them. They're not going to be serial killers. Now, they may have killed an ex-husband or something, but they're not going to kill a whole bunch of them. Okay, so we know the women are going to be okay. So, if this is our numbers for the weekend, how many couples can we get? 5. Nobody said 8. You understand that just instinctively, that the men are in excess. The women are the limiting reagent, if you're talking chemistry talk. Now, your book, you can read your book if you wish, but it's a boring analogy. They talk about making ham sandwiches. And for the ham sandwiches, you need 2 slices of bread and 1 slice of ham. Well, if you had X number of slices of bread and X slices of ham, how many sandwiches could you make? Boring. Okay, I have always discovered if I talk about sex, or if it's not a prostitution ring, if we talk about sex, we talk about your grades, or we talk about your money, you always remember, okay, the idea. So, here's the main point from that. The limiting reagent dictates the amount of products you get. That's why in a previous problem when they said, you got excess oxygen? Well, we don't care about the oxygen. Okay? So, the limiting reagent always dictates how many couples. And it doesn't matter if 8,000 men had filled out the application. If only 5 women, we're only going to get 5 couples with the rules that we have imposed. Okay, now let's look at this problem.